All right. So we had some technical difficulties with the last one. So I'm gonna pick up on activity 2. Well, activity 1, um, part 2. So hopefully that won't happen to us again. If it does, then I'll just record this video at another time. So we already did this activity 1. So activity 2, what we'll do is we are looking for when the input is 6, the output is -3, right? And so here we're just basically finding f of 6, right? F of 6 equals 3 times 6 minus 7. All right. Because we have, let's do it like this. So 18 minus 7, which equals 11. All right, so f of 6 equals 11, okay? But we're looking for the output to be -3, so that's not gonna work. All right, so let's clear this out. All right, now let's look at g of, let's look at g of 6. All right, so 3 times -1, so g of 6 equals -3, okay? So that's our that's what we were looking for. So this is your solution. Y'all, I'm tired. Very tired. So y'all excuse the yawn. So this is part 2. G of x is going to be, or G of x is going to be the one that if you put the input at 6, the output is -3. All right, let's clear this out. Let's go on to the next slide. Activity 1, part 3, it says, which function value f of x, g of x, h of x, or k of x is the greatest when the input is 0? So we got to do each of these, right? So f of 0 equals 3 times 0 minus 7, which is 0, 7. So f of 0 equals -7. All right. G of 0 equals 3 times 0 minus 7. So this is 3 times -7. So G of 0 equals -21. All right. All right, so boom. Yeah, boom. Let's do H. H of 0. H of 0 equals 0 over 3 minus 7. H of 0 equals 0 minus 7. H of 0 equals -7. And then the last but not least, let's do it in black. K of 0 equals 0 minus 7 over 3. So this is -7 over 3. So K of 0 equals -7 over 3, which -7 over 3 is actually -2 1/3. So it's asking us which is the greatest. And actually, out of all of these numbers, -7 over 3 has the largest value. So it's actually going to be this one, okay? So that's the largest value. Now, is what about when the input is 10? Let's clear that out. So let's do this real fast. When the input is 10, f of 10 equals 3 times 10 minus 7. So f of 10 equals 23. Let's do g of 10. G of 10 equals 3 times 10 minus 7, which is 3 times 3. So G of 10 equals 9. All right, let's do H of X equals 10 over 3 minus 7. So H of X equals, basically this would be 10 over 3 minus 21 over 3. So this equals negative 11 over 3. Okay. And then let's do the last one. K of X equals 10 minus 7 over 3, which 10 minus 7 is 3. So K of X equals 3 over 3, which is equal to 1. All right, so which one has the greatest value? So it would actually be f of x when the input is 10. Excuse me. Notice you want to go through each of these and actually work them out individually. But show your work. You want to get used to doing the input and output. All right. Let's see what's next. Activity 2, it says a square that has a side length of 9 centimeters has an area of 81 centimeters. The relationship between the side length and the area of the square is a function. Complete the table with the area for each given side length. Okay, so if I have a side length now, you all should remember how to find the area of a square. All right, so here we got, boom, 1, 4, 16, 36, and S squared. Okay, so as you can see, it says write a rule for a function A that gives the area of a square in centimeters squared when the side length is S. So A of S is equal to S to the second power. All right. A of S, the reason that I used A right there, because write a function rule for A. Okay. Y'all, I really apologize for all this yawning. I am dog tired. Here we go. So then it says, what does A of 2 represent in this situation? So remember, we have A of S is equal to S squared. So A of 2 is equal to 2 squared. Okay. But the answer to is technically A of 2. Let's clear this part out because that's not what I want to do. A of 2 represents, let's see, let's make this smaller. A of 2 represents the area of a square with sides length of 2 centimeters. All right, so A of 2 in this case represents the area of a square with side length with the side length of 2 centimeters. Okay. So that's that. How do we go back? All right. Part C. Let's clear this out. Clear. All right, so it says on the coordinate plane, sketch a graph of this function. Okay. So remember, we had 1, 4, 16, 36 s squared. All right, so when the side length is 1, we have area of 1. 2, we had 4. 3, we had 9. 4, we had 16. 5, we got 25. 6, we got 36. All right, so we just 7, we got 49. So that's what the graph looks like. All right. Let's clear that. Here's another question on activity 2. Now we're at the top of page 58. It says a roll of paper is 3 feet wide. Can be cut to any length. If we cut a length 2.5 feet, what is the perimeter? Now, one thing you have to picture in this case is if you got this rectangle, right? Let's imagine we have 3 feet. So this is 3 and then 2.5. Now, I understand this looks terribly incorrect, but just roll with me. So what is the perimeter? Well, the perimeter is you add up all the sides. So P equals 3 plus 2.5 plus 3 plus 2.5. All right, and if you add all of those up, then the perimeter equals 3, 6, 7, 8, 9, 10, 11 centimeters. Actually, I put feet. No, it is feet. Okay. 11 feet. All right. Let's go further. It says a roll of paper is 3 feet wide, can be cut to any length. Complete the table with the perimeter for each given length. So when I do this, I'm going to just fill these numbers in. I have 8, let's see, 8, 10, 18.6, 28, 6 plus 2L. All right. And all I did was I took, remember for each one. So for example, this one, right? It's 3, 3, 2, 2. For this one is 3, 3, 6.3, 6.3. All right. For this, 3, 3, 11, 11. And then, so this is the formula that I got. It says, what does P of 11 represent? And P of 11 just represents the perimeter. P of 11 represents the perimeter of the roll cut to a length of 11 feet. That's all it represents. And that's that. Okay. And then we can actually go and graph these different value. So we're graphing the values that from the table on 2B. So notice it says when it was 1, it had a perimeter of 8 feet. 2, 10. 3, 12. Actually, no, we don't need to do that. 3. Let's do 6.3. So 6.3. 18.6. So somewhere around there. 11. We don't have 11. But if the side length is 3, if we can use these, so if the side length is 3, right? So 3 plus 3 is 6. 6 plus 6 is 12. So it'd be right there. That'd be right there. This one would be right here. And this one would be like this. And that'd be the graph. That'd be the graph. All we're doing is we're taking the order pairs from that table. So the table, if you could see, let me take this off. So we got the values from this table. When the side length was 1, the perimeter was 8. When the side length was 2, the perimeter was 10, and things like that. So we're just using those coordinates for this. All right, let me hurry up so I can wrap this video up. We're gonna skip activity 3, and we're gonna go on to activity 4, which should be very simple. Now, activity 4, you're gonna use Desmos. So I'm going to stop sharing this, and I want to go to Desmos. Let's see if I can find Desmos. All right, we'll go to the calculator. Now, when you look at Desmos, right, I'm gonna do my best to let's go screen. All right, so Desmos is now you're not gonna be able to see the actual picture. Maybe you can. I don't know if it'll let me do both of them. Let's see. Nope, it's not. So when I look at Desmos, right? Activity 4 basically talks about how would you find so I'm going to read it. It says the function b is defined by the equation b of x equals 10x plus 25. Use the graphing technology to find the value of each expression. So the first thing that we can do, we can actually say, let's put in the equation b of x equals 10x plus 25. All right, and so now it gives you, as you can see, it gives you the graph. Okay, so now when I look at the graph, we want to find the value of each expression, b of 6. All right, let's zoom this in. So let's zoom this in. Just a second. So it's really high to find b of 6. So what we're going to do, we're going to look at a simpler way to do this. Let's say b, b parentheses 6. Boom, 85. All right, so now we typed it in, b of 6 is 85. And you can actually zoom in and out. Like we could do this, we can add a table. So as you can see, when you add this table, boom, it tells you the different values of x and f of x. Okay, so now we just made your life easier by putting it in Desmos. Now you won't be able to put everyone in Desmos, but just remember. So like if I wanted to find b of 4, let's take this out. Let's find b of 4, right? B of 4 is 65, as you can see. All right, so now let's go to the settings, and let's do a table. All right, let's move this one. Hey, hold up, maybe it'll let me move this one up. All right, so I got this table now, and now that I got this table, let's see if we want to find b of, let's go through letter b of 2.75, right? Oh wait, I'm tripping. I don't know what that was. B 2.75.